This is Geometry Homework Solutions for 8-4, the multi-step trigonometry problems. Here we go. All right, so you always start with what we know. We know that we have a 15 here. We eventually need to find x, just in problems 1 and 2, and then it gets a lot harder in 3 and 4. So in problem number 1, to get from 15x, we're going to go to this height here of the triangle, and then from that height down here to x. So I'm going to label this as an intermediate step. I'm going to label that y. So I'm going to extract this triangle on the left. On the left, I have this triangle. Let's see if it makes it nice and neat. I have this triangle that's a 90-degree angle here, 48-degree angle up here, a length of 15, and this length of 5 that we're trying to find. So let me label this with our O, A, and H. Opposite of 48 is over here, our hypotenuse of 15, and our adjacent of y. So in our SOHCAHTOA, let me write down SOHCAHTOA. Notice that we do not want O at all. So I'm not using O, I'm not using O, and that means I'm using cosine. So let me set up cosine. I have cosine of our angle, 48 degrees, and that's always going to be equal to adjacent over hypotenuse. Our adjacent is y, our hypotenuse is 15, and then it's very easy to solve. I just multiply both sides by 15, and I get y is equal to 15 cosine of 48. And we can approximate that with a calculator. 15 cosine of 48. Coming back over here. 15 cosine of 48. And that's going to be about 10.0, almost on the dot. So we'll say that this is, and then we need to update the app. Thanks for doing that right in the middle of the video. And I think we said that that's going to be 10, almost on the dot. So now I'm going to extract this triangle on the right-hand side, and I'm going to redraw that over here in blue. So I have this right triangle, and we have it labeled 54. We know that this is x, and we just figured out that this height is 10. So let's go ahead and label our O, A, and H. Opposite of 54 is O. Our hypotenuse, and by default, for process elimination, that's our A. So again, in this one, we're not using hypotenuse. We're not using hypotenuse, not using hypotenuse. So we're using tangent in this case. Let me set up our function. We have tangent of our angle, 54. That's going to be equal to opposite over adjacent. Again, O over A. Our opposite is x. And our adjacent is 10. Again, multiply both sides by 10, and we get x is equal to, I don't know what I'm writing here, 10 times tangent of 54. And 10 times tangent of 54, 10 tangent of 54 is 13.8 rounded. So 13.8. So x is about, I should say, is approximately equal to, x is approximately equal to 13.8. Let's check the back to see if we got it. 13.8. 13.8. Excellent. Moving on to number 2. Come on, iPad. In number 2, I'm starting with what I know. I know this 10, and I need to get x. So I'm going to go from 10 to this height, and then from this height to this hypotenuse. So let me extract this triangle on the left and see what we're dealing with. We have this triangle on the left, and this triangle has a length of 10, a length, or I guess an angle of 40 up here in the top right. And then we'll label this y. This height here is going to be y. Let's go ahead and label our O, A, and H. Opposite of 40, and this is going to be the adjacent and hypotenuse. We're not using the hypotenuse, so that means we're going to be using tangent. Let me set up our trigonometric function. So I have tangent. I don't want to use that color. I have tangent of our angle, 40, and that's going to be O over A. So it's going to be 10 over y. So to solve for y, we're going to switch these diagonals. Switching the diagonals gives us y is equal to 10 divided by tangent of 40. And I'm going to say that this is approximately equal to 10 over tangent of 40. Let's see. 10 divided by tangent of 40 is 11.9. 11.9. So now we know that the height of that triangle is 11.9. Let's go ahead and extract that triangle on the right-hand side. So this longer triangle on the right-hand side has a length up here of x, this angle down here of 24, and we now know that the height of left and right, to the left of our triangle is 11.9. So again, that just came from this length as 11.9. We know that y is 11.9. So in order to find this x, let's go ahead and label our O, A, and H. Opposite of 24 is over here. Hypotenuse is x. Adjacent is down here. In this case, we're not using the adjacent. We're using opposite and hypotenuse. So that's going to be sine for the SO in the SOHCAHTOA. If I write out my sine, I have sine of my angle, 24. And that's going to be equal to opposite over hypotenuse. It's going to be 11.9 over the hypotenuse of x. We need to solve for x. The way that we do that is by switching these diagonals. That means that x is going to be equal to, I want to say 11.9 all over sine of 24. So I'm going to say 11.9 over sine of 24. 11.9 divided by sine of 24. And I get 29.3. It's not 0.2 because that 2 is followed by 5. So 29.3. And I get x is about, did we say 29.3? 29.3. Box it, and let's check. 29.3. 29.3. We're on to number 3. So 3 is the first multi-step problem. To do our multi-step problem, we need to find the area. This is the key difference between the first 2 problems and these last 4 problems, last 6 problems, or just last 4 problems. So in order to find, the area of a triangle, remember your formula for the area of a triangle. The triangle area, this is going to be equal to 1/2 times the base times the height. So we need the entire base, we need this entire base, and we need the entire height. So how do we do that? And I want to be careful with the letter H here because sometimes that means hypotenuse. That's clearly not the hypotenuse of either triangle. So let's call that thing the altitude. We'll call it the A, altitude of the triangle. All right, so if that's the altitude of our triangle, then I need to find this length in order to add it with this length to get the entire base, and I need to find this length. So I'm going to go ahead and label this length over here x. We need to find x, and we need to find, I can't say altitude because that's adjacent, huh? That would be silly. We'll just call it y. All right, so those are the 2 values that we need to find. Let's go ahead and extract this triangle on the left and rewrite it. I have this exact triangle on the left, and we have an angle of 58 degrees on the top. We have this length of 43 degrees on the bottom, and we know that we want y over here. So again, labeling my triangle with opposite and adjacent. Oh, I see, bud. And hypotenuse. I'm recording a video now. I can't help you, bud. So I can't use hypotenuse. I'm using O and A, so that's going to be a tangent function. Setting up tangent, I have tangent of my angle of 58, and that's going to be equal to opposite over adjacent, or 43 over y. To solve for y, we're going to switch our diagonals, and I get y is equal to 43 divided by tangent of 58. And 43 over tangent of 58. 43 divided by tangent of 58 is about 26.9. Again, that 8 is rounded up because followed by a 6, which is a 5 or greater. So 26.9. I'll come here and say this is about 26.9. So that's good to find. We now need to use this length to find this length down here. So let's extract that triangle on the right and redraw that. This triangle on the right looks like this, more or less. And I have an angle of 51 in the top. I have this length of x that we're trying to find. And we now know that the height of this triangle is 26.9. And we need to use trigonometry. So I'm going to be saying opposite of 51, adjacent of 51, and the hypotenuse of the triangle. And from there, I'm saying, okay, I'm not using hypotenuse. I'm using A and O, which is, again, another tangent function. So I'm going to say tangent of our angle of 51 in this case is equal to, it's TOA, so O over A is going to be x over 26.9. And again, I'm going to switch these two, and I'm going to get x, sorry, not switch these two. What am I saying? I'm going to multiply both sides by 26.9, so I get 26, I'm just going to say x first. X is equal to 26.9 times tangent of 51. So let's do that times tangent of 51. 26.9 times tangent of 51, which rounded is 33.2. So I get this length of 33.2. X is about 33.2. So now I have all the pieces I need to put them together. So in total, the entire base, remember the base is this piece plus this piece, This x is 33.2, so I'm going to do 33.2 plus this 43 for the entire base. So my base is going to be 43 plus my 33.2, which is going to be 76.2. And my height, I already know, the height of my triangle is my y value. My y value is this y value, and that y value is 26.9. 26.9. And then I'm just kind of plugging in the formula. So it's going to be the area of the triangle is 1/2 of base times height, which is 1/2 of 76.2 times 26.9. And I'm going to actually split the screen because I might forget all of this. So I'm going to split the screen with my scientific calculator, and I'm going to say, what is 1/2 times 76.2 times 26.9, and I get 1024.89. So move this to the right a little bit. So this is, again, we're rounding, so I'm doing the approximately symbol. This is 1024.89, and then we're going to check the back and see if that's correct. 1024.89, 1024. Oh, I shouldn't have said 89. I should have said just 0.9. I should have rounded it correctly. So I can come back here and say that this is really just 0.9. 0.9. I should box it. Yeah, there's a lot of work that goes into these problems. Let's do the next one. So let's go ahead and analyze again. We want to find this length and we want to find this length, because if we have both of these, then we'll have the entire base, and I need the height. So let's find y first. I'm going to find y first because I can go from something I know to y. I can't do x first because I need this intermediate height value first. So extracting this triangle on the left, you'll notice that we have our 38-degree angle on the left, and we have this length of 6 on the bottom, and we're trying to find y. So if I'm labeling my O, A, and H, notice that we're not using H, meaning we're using another tangent function. So I'm going to say underneath this that tangent, I want to use a different color though, tangent of my angle of 38 degrees is going to be equal to, so it's TOA, so O over A, so it's going to be y over 6, and multiply both sides by 6, and y is equal to 6 times tangent of 38. And I should really just leave the calculator up on the screen, shouldn't I? So I'll leave the calculator on the left-hand side, and I'll put my notes on the right-hand side. That will be a little bit more efficient, and it only needs that much room. So I'm going to type in 6 times tangent of 38, and this is about 4.7. So this is about 4.7. All right, so now let's extract this triangle on the right-hand side. So if I redraw this, I have this triangle with a 60-degree angle, and I have an x here. I now know that this height over here is that same length that we just got, which is 4.7. So I can say this is 4.7, and let's label our O, A, and H. So let's come over here and label, come on, colors. I have O, A, and H, and yet again, I'm not using hypotenuse, I'm using O and A. OA sounds like TOA, so I'm using tangent. So here we go. I'm doing tangent. Which remote? It looks like it's on the floor. So I'm going to say tangent of 60, and that's going to be equal to OA, so O over A, 4.7 over x, and to solve for x, we're going to switch the diagonals, and I get x is equal to 4.7 divided by tangent of 60. We can type that in on the calculator over here. So I'm going to type in 4.7, please, divided by tangent of 60, and rounding, that's about 2.7. So this is rounding about 2.7. And now we have all the pieces, right? So again, the area of a triangle is always going to be 1/2 of base times height. Well, the base is going to be 6 plus x, and we know that x over here is, we just got x is 2.7. So the base is 2.7 plus 6, or 8.7. So this is going to be equal to 1/2 of 8.7 times the height. The height is y. This is our height. And our height down here is 4.7. So times 4.7. Type this into the calculator. And I get 1/2 times 8.7. Not divided by, but times 4.7, and I get 20.4. This is equal to 20.4, and box it. Let's see if we got it right. 20.4. 20.4. Excellent. And moving on to the second to last problem. Again, we're trying to find, this has a lot of unknown values. We need to know this length, we need to know this length, and we need to know that length. My z's have a little bar through the center because we need the entire base and we need the entire height. So there's three things that you need for this problem. So let's go ahead and extract that triangle on the left and see how we can find these values. So the triangle on the left had an angle of 49 degrees down here, and we have 46, an x, and a y. Which one do we want to do first? It doesn't really matter. Let's pretend not pretend. Let's actually solve for x first. So if I'm solving for x, let's label our triangle. This is that's not opposite. Opposite of 49 is over here. This is the adjacent, this is the hypotenuse. So if I am after just these two, an a and an h, sounds like ka, from toa. So that's going to be cosine. I'm going to say that cosine of my angle 49 is going to equal to ka is x over 46. X over 46. And then I can multiply both sides by 46, and I get x is equal to 46 times cosine of 49. And that is what calculator? It's going to be 46 times cosine of 49, and I get 30.2. 30.2. Okay. What if I want to find y? I have to set up a new trig value. If I want y and not x, then I'm going to use these two together, and the O sound comes from coming from sine, right? So I have sine of my angle. My angle in this case is still 49. And so is opposite over hypotenuse, so it's going to be y over h. And I don't want to say h here. I know h is 46. Again, to solve for y, I'm going to multiply both sides by 46, and I get y is equal to 46 times sine of 49. And we're going to use the calculator to approximate that. We're going to say 46 times sine of 49, and I get 34.7. 34.7. All right, we're 2/3 of the way there in terms of our unknown values. Now we just need to find z, and that comes from this triangle on the right. So let's go ahead and redraw that triangle on the right. Do that up here. So with this triangle on the right, what do we have? We have this right angle. We have a 28 degrees. We know that the y value is going to be that height. The y value is 34.7, so I can say this length is 34.7. That's supposed to be a 7, not a 1. 7. And I'm after this length of z. So labeling this, we know that opposite of the angle, the adjacent of the angle, and the hypotenuse of the angle. In this case, we're not using the hypotenuse, we're using the oa. That sounds like toa. We're using tangent of this angle. So I'm going to say tangent of our angle 28 is going to be equal to oa, so it's o over a. It's 34.7 over z. To solve for z, we're going to switch our diagonals, and we're going to get z is equal to 34.7 over tangent of 28. And we can approximate that. Am I running into the next problem? Yes, I am. So I'm going to do it down here. Z is approximately, calculator helps out, 34.7 divided by tangent of 28. And I get 65.3. 65.3. We have all the pieces to plug into our formula. Let's go ahead and do it. Again, if I'm looking for area, the area of a triangle is always equal to 1/2 times base times height. We don't know the base yet, but the base is going to be adding our x and our z. So let me go ahead and do base. I'll do it like up here. Base is going to be x plus z, and x is 30.2, and z we just found was 65.3. 60, oops, that's not 60. 65.3. And these together is going to be 95.8. 95.8. So filling into our formula, we've got this. We've got 1/2 times the base, which is 95.8, times the height. The height in our equation was y, and y was equal to 34.7. So times 34.7. I just need to type this in the calculator. It's going to probably have some rounding, so I'll say the approximately symbol preemptively. I'll say 1/2 times 95.8 times 34.7, and I get 1,662.13, or just 0.1. A lot of work. I'm really hoping that we didn't make a mistake at the very beginning. 1662.1. Ooh, I'm off by a little bit. I'm wondering if it was due to rounding. If this were to happen to you on a quiz or test, if you're this close, I would probably give it to you. I have a feeling that, let me read the instructions. It says round to the 10th for all work, and I have all my work over here on the calculator side. Did I make any rounding mistakes? Sometimes that happens. 65.3 is correct. Was 34.7 correct? 30.1, oh, sorry, it was 30.2. I got all that right. There's a way to do this with exact values. Let me show you a cool little trick. We can make this as perfect as possible. Check it out. So I say, what if I say a random letter? Like I'll say sine of 49. So 46 sine of 49, those are y values. So I'll say y is equal to that. I'll say x was equal to that. And I'll say z was equal to that. What I can do in here, instead of typing in these values, is I can use those letters now. 1/2 of, I can come over here and start my parentheses, of, and that was x plus z. X plus z. And then that was being multiplied by the height, and height was y. So times y, and I can get an exact number. So without any rounding, this is storing my answers. Without any rounding, my answer is actually 1,656.7. Is that what they got in the back? 1656.7? 1656.9. I mean, I'm a lot closer by storing my answers. The point that I'm trying to take away from this is on the quiz, sometimes my answer won't be perfect to your answer, and if it's off by just a little bit, I'm not going to take off any points for this upcoming quiz. Sometimes it's important to know how to round. In these questions, they're off a little bit. I'm not sure why. If you find a mistake in my work, please let me know. I would love to know that I have still things to learn. Let's do number 6. We got a lot to work on. So we need to know this length, we need to know this length, and we need to know this length. If we have all those pieces, then we can plug them into our formula like we were doing in number 5. So here we go. I have this triangle on the left, which is the skinny guy. And then we have a 70-degree angle down here, right angle here. We have an X, we have a Y, and we have a 10. Labeling this triangle with O, A, and H. Opposite of 70 is over here. Adjacent and hypotenuse. Let's find X first. To find X, I'm doing the H and A. So that's the K sound, the C-A-H sound. So that's going to be cosine of the angle of 70 degrees is equal to A over H, which is equal to X over 10. If I multiply both sides by 10, I get X is equal to 10 cosine of 70. And that is about what? So I'm going to say 10 cosine of 70. And that's about 3.4. 3.4. Let's find y. So if I'm setting up and trying to find y, that is the opposite and hypotenuse that I'm going to be dealing with. And that's the so symbol, or the so sound. That's S for sine. And then sine of the angle 70 is going to be O over H, which is going to be y over 10. Multiply both sides by 10, and I get y is equal to 10 times sine of 70. So let's go ahead and approximate what that is with the calculator over here. That's going to be 10 times sine of 70, and I get 9.4. 9.4. All right. Finally, we need to find z, and z comes from this bottom part of the right triangle. So let's redraw that right triangle over here to the right. So here's the right triangle, and it has a right angle here. We know the angle is 44 degrees up here. We know that the height over here is 9.4, and we're trying to find this length z. So let's label the triangle O, A, and H. So opposite of 44, adjacent to 44, and hypotenuse. Again, we're not using hypotenuse, we're using O and A, which is the TOA sound, meaning we're using a tangent function. Let's come back here and do that in blue. So we're taking tangent of the angle of 44, and that's going to be equal to OA, or Z over A. Sorry, O over A, that's going to be Z over 9.4. Multiply both sides by 9.4, and you get Z is equal to tangent of 44 times 9.4. I don't know why I didn't write the 9.4. Here, let me try that again. 9.4 times tangent of 44. And that z value, therefore, is about what? It's coming down here. And that's going to be 9.4 times tangent of 44. Wait a sec. Did I do something wrong in the last problem? Because I'm just realizing the last problem, we divided by tangent of 44. Oh, that was because the angle was down here, but now the angle is up here. So that makes sense. I was trying to catch the mistake in the last one. I'm still thinking about it. 9.4 tangent of 44. I get about 9.1. Z is about 9.1. So to find the entire base, we're going to do, the base is really equal to x plus z. And x is 3.4. And z is 9.1. 9.1. Adding these together gives you 12.5. 12.5. And we know the height, so I'm ready to do the area is equal to 1/2 times the base times the height, or 1/2 times the base, which is 12.5, we just found that, and times the height. The height is this y value up here, which was down here, that's 9.4, so I'm going to say times 9.4. This probably won't match the back, judging by the last problem, but let's see how close we get. I have 1/2 times 12.5 times 9.4, I get 58.8. So this is equal, I guess I'm approximating because I am rounding here. This is about 58.8, which is my final answer. Let's see, 58.8 or something close. Whoa, we got on the money there. Why was the last one off? There's some mistake that we made then, right? Or maybe the answer key is wrong. I can change this 34.7 into an answer. Check this out. So 34.7, if I just type in answer, then it's really exact. I get 1657.2. 7.2. Yeah, that's even farther away. I'm not sure what the mistake is. If you guys can find a mistake in number 5, please let me know. That is the entire homework for Geometry Homework 8-4. Thanks for watching.